A Falcon 9 rocket just spotted something moving on the surface of an object from another star system. That was the claim that recently exploded online, suggesting SpaceX secretly sent a mission to an ancient interstellar comet. But what is the truth behind this cosmic visitor and the viral rumors? The reality is even more fascinating than the fiction, and it forces us to confront a critical question about humanity's future in space. Let's explore this together. What makes 3I Atlas special? So what's the big deal about this specific visitor? Imagine an object older than our own sun, which is about 4.6 billion years old, carrying secrets from a star system we've never seen. That's what we're talking about here. While the name 3I Atlas is fictional, it's clearly inspired by real objects like Comet C 2023 A3 Tsuchinshan Atlas. This comet is a long-period visitor from the Oort cloud, a theorized sphere of icy bodies over 150 trillion kilometers away. True interstellar visitors like the ones discovered by astronomers Robert Warwick and Gennady Borisov come from even farther. Warwick's discovery, Oumuamua, was a 400-meter-long enigma traveling at a blistering 87.3 kilometers per second relative to the Sun. Borisov's comet was moving at a more sedate but still incredible 32 kilometers per second. These objects are time capsules containing the original chemical ingredients from another star's formation. Scientists believe analyzing even a gram of material from one of these could reveal isotopic ratios and molecular structures that don't exist in our solar system. It's like receiving a message in a bottle from across a cosmic ocean. This isn't just another rock, it's a pristine sample of galactic history delivered right to our doorstep. The Falcon 9 connection debunked. Let's get straight to it. Did a Falcon 9 rocket actually intercept anything on a comet? The short answer is no. The viral claim suggested a secret SpaceX mission, but the reality is much more routine. Public launch records show that Falcon 9 rockets are constantly lifting off, with SpaceX having completed over 100 launches in 2023 alone. Their missions are focused on deploying batches of 22 to 23 Starlink satellites into low Earth orbit, typically at an altitude of about 550 kilometers, or launching sensitive payloads for the National Reconnaissance Office. A Falcon 9's job is to provide the initial boost into a specific orbital slot around Earth. It is not a deep space interceptor. The idea of a Falcon 9 spontaneously chasing down an interstellar object moving at over 100,000 kilometers per hour is pure science fiction. The rocket that places satellites in orbit simply doesn't have the fuel, the engines, or the trajectory to perform such a maneuver. It's like using a city bus to try and compete in a Formula One race. The bus is great at its job, but it's the wrong tool for that particular track. The viral story was compelling, but it fundamentally misunderstands what these remarkable rockets are built to do. The physics of interception. Why couldn't a Falcon 9 just go and chase a comet? The numbers are staggering, and it all comes down to a concept called delta V, the currency of space travel. To get a payload to low Earth orbit, a Falcon 9 provides about 9.4 kilometers per second of delta V. To catch Oumuamua, studies from the Initiative for Interstellar Studies under a concept called Project Lyra estimated a required delta V of over 30 kilometers per second, maybe even up to 70 kilometers per second depending on the launch window. That's an order of magnitude more energy. Our fastest spacecraft, the Parker Solar Probe, will reach a mind-bending 192 kilometers per second. But only after 7 gravity assists from Venus over 7 years, using the Sun's own immense gravity as a slingshot. It needed a massive Delta IV heavy rocket just to get started. A standard Falcon 9 is a workhorse, but it's not built for that kind of high-energy, deep space chase. It would be like trying to jump onto a bullet train as it speeds through your station. You can't just run and catch it. You need a vehicle that can match its speed and trajectory perfectly. And that requires an astronomical amount of energy planned far in advance. Alien chemistry possibilities. Here's where things get really fascinating. What if these interstellar visitors are carrying chemical recipes we've never seen before? An object formed in a completely different stellar environment would be built from a different cloud of gas and dust. Telescopic analysis of 2I Borisov, led by scientists like Dennis Bodowitz, revealed it contained anywhere from 9 to 26 times more carbon monoxide than the average solar system comet. This suggests it formed in an extremely cold, carbon-rich region around its home star. This raises a profound question, one often explored by thinkers like Harvard astronomer Avi Loeb. Could these objects carry complex organic molecules with structures fundamentally different from those on Earth? Life here is based on left-handed amino acids. Finding right-handed versions on an interstellar object would be revolutionary. It would be powerful evidence for the theory of panspermia, the idea that the chemical seeds of life are spread throughout the galaxy on objects just like these. If we could analyze a sample, we might find that the building blocks of life are common across the cosmos, but maybe they follow slightly different rules. It would be the ultimate test of whether life as we know it is a cosmic fluke or a universal blueprint. 3 missed opportunities. The frustration for scientists is that we've seen these messengers fly by, but we've been unable to do anything but watch. We are 3 for 3 on missed chances. First, there was one Oumuamua, discovered on October 19, 2017, by Robert Warwick. By the time astronomers realized how strange it was already rocketing out of our solar system, far too fast to be caught. Its bizarre 400-meter-long cigar-like shape and its mysterious acceleration still spark debate. Then, on August 30, 2019, amateur astronomer Gennady Borisov spotted 2I Borisov. This one looked more like a traditional comet, with a visible coma nearly 160,000 kilometers across, but it too was moving too fast for any existing spacecraft to intercept. The window of opportunity to launch a mission was just a few months, far too short to build and prepare a spacecraft from scratch. Each of these objects represented a unique, fleeting opportunity to study matter from another star system up close. Instead, we were left observing from millions of miles away. It's like having priceless ancient artifacts float past your window, just out of reach. Future intercept technology. So, are we doomed to just watch these cosmic treasures fly by forever? Not necessarily. The European Space Agency, or ESA, is already building a solution. It's called the Comet Interceptor mission, planned for launch in 2029 aboard an Ariane 6 rocket. This is a game changer. The spacecraft won't have a specific target when it launches. Instead, it will travel to the Sun-Earth L2 point, a stable gravitational parking spot about 1.5 million kilometers from Earth, and it will wait. It will hibernate there for up to 3 years, acting as a rapid response system. When astronomers, perhaps using the upcoming Vera C. Rubin Observatory, discover a new long-period comet, or ideally, a new interstellar object with a reachable trajectory, Comet Interceptor will be ready to go. Once it gets its target, the main spacecraft will release 2 smaller probes. Together, the 3 vehicles will fly through the comet's coma from different angles, creating a 3-dimensional profile of a pristine object. This 3-for-1 approach will give us unprecedented data on the object's nucleus, its gas, its dust, and the surrounding plasma environment. This mission is our first real shot at studying one of these messengers up close. Scientific implications. Let's talk about the bottom line. What's at stake here? The discoveries from intercepting an interstellar object could be transformative, honestly rewriting textbooks on multiple fronts. We're not just talking about seeing another space rock. We're talking about answering some of the deepest questions in science. First, its chemical composition could provide a direct sample of the materials that form planets in other star systems. We could learn if the building blocks of rocky planets and gas giants are the same across the galaxy. Second, studying its isotopic ratios, the specific blend of neutrons in its atoms, could give us a definitive fingerprint of its origin, proving beyond any doubt it came from another star. And perhaps most importantly, as scientists like Avi Loeb argue, we should be open to all possibilities, including looking for chemical signatures of technology. Confirming unique organic molecules would provide powerful evidence for panspermia, suggesting the ingredients for life are widespread throughout the universe. This is about understanding our own origins, the prevalence of life's ingredients, and our ultimate place in the cosmos. It's a chance to move from speculation to direct evidence. Trajectory analysis and mysteries. So how do we even know these objects are from another star system? Well, the answer actually lies in the mathematics of their journey. Objects in our solar system orbit the sun in closed ellipses, but interstellar visitors travel on a hyperbolic trajectory, a one-way trip really. Their sheer speed is the giveaway. But you know, the path itself can hold deeper secrets. For example, a team led by Marco Micheli of the European Space Agency confirmed that Oumuamua had a slight non-gravitational acceleration. It was a tiny but persistent push of about 1.5 millimeters per second squared. The leading scientific theory is that this was caused by the outgassing of hydrogen ice, creating an invisible jet effect. However, the lack of a visible coma to confirm this keeps the mystery alive and, honestly, fuels speculation. This riddle just highlights how much we have to learn. Analyzing the precise path of future visitors could tell us if they are solid, inert bodies or if they're actively shedding material in ways we can't easily detect from Earth, which really challenges our models of what a comet even is. The official facts. So, let's set the record straight, separating the viral fiction from the scientific facts. The object that fueled recent excitement is likely based on Comet C 2023 A3 Tsuchinshan Atlas. It was first spotted on January 9, 2023, and confirmed on February 22, 2023. ATLAS itself stands for Asteroid Terrestrial Impact Last Alert System, a network of telescopes designed to spot near-Earth objects. This comet is not interstellar, it's a long-period comet from the Oort cloud. Its orbit is incredibly long, taking tens of thousands of years. It made its closest approach to the Sun, its perihelion, on September 27, 2024, at a distance of about 58 million kilometers. Its closest approach to Earth was on October 12, 2024, at a safe distance of about 71 million kilometers. Its nucleus is estimated to be several kilometers in diameter, and to be perfectly clear, no spacecraft from SpaceX or any other agency has intercepted this comet. The Falcon 9 launches are real, but they are completely unrelated. The bigger picture. The Falcon 9 story, while inaccurate, highlights a much deeper truth. Humanity is now at a crossroads. For the first time, we have the technology to not just observe these messengers, but to potentially reach out and touch them. The detection of multiple interstellar visitors in just a few years suggests these encounters are actually pretty common. And with new tools like the Vera C. Rubin Observatory coming online, its director, Zeljko Ivezic, predicts we might soon be spotting dozens of these objects every year. We are no longer just passive observers on the shore of the cosmic ocean. We are building the ships to sail it. The development of missions like ESA's Comet Interceptor is the first step toward a proactive strategy. The real question is no longer can we do it, but will we commit? Some scientists are now pushing for a permanent, ready-to-launch intercept program. It's a question of priorities. The choice we make now will define the next great era of space exploration and could determine if our generation is the one that finally answers the question of what lies beyond our cosmic neighborhood. So, Falcon 9 didn't literally chase a comet, but the conversation it started is critical. We are on the verge of being able to sample another star system. The next visitor is coming, and the one after that. The only question is whether we'll be ready to answer the door when it knocks. What do you think? Should we be building a permanent intercept mission, ready to launch at a moment's notice? Let us know your thoughts in the comments below. Don't forget to like, subscribe, and hit the bell icon so you don't miss our next exploration into the mysteries of the cosmos. Thanks for watching Future Facts. Voyager 1, humanity's pioneering explorer, has defied all expectations since its 1977 launch. Now, more than 4 decades into its journey beyond the heliosphere, it continues revealing hidden cosmic phenomena. Recent encounters in deep space have confirmed fears long held by scientists about the unknown dangers and mysteries lurking in interstellar space, fundamentally redefining our understanding of the universe and our place within it. The birth of a star sailor. Voyager 1 emerged from an era of unprecedented ambition and innovation, conceived during the 1970s as part of NASA's ambitious Voyager program designed to explore the outer solar system. Built by the Jet Propulsion Laboratory with project scientist Ed Stone overseeing the mission direction, Voyager 1 was equipped with an advanced suite of scientific instruments specifically designed to survive the harsh environment of deep space. Launched on September 5, 1977, it embarked on what would become humanity's most audacious journey into the cosmic unknown, destined to become the first human-made object to reach true interstellar space. The spacecraft carries humanity's hopes and dreams across the galaxy, immortalized in the included golden record containing sounds and images representing Earth's incredible diversity. This remarkable machine, weighing just 722 kilograms, would eventually travel farther from home than any other human creation, becoming our species' first ambassador to the stars and opening entirely new frontiers in space exploration that continue inspiring generations of scientists and dreamers worldwide. The Grand Tour. The Voyager mission represented an unprecedented grand tour of the outer planets, taking advantage of a rare planetary alignment that occurs only once every 175 years. Voyager 1's carefully planned trajectory included spectacular flybys of Jupiter in 1979 and Saturn in 1980, delivering breathtaking images and groundbreaking scientific data that completely transformed our understanding of planetary science. The spacecraft's discoveries included detailed observations of Jupiter's Great Red Spot, revealing its complex atmospheric dynamics, and unprecedented views of Saturn's intricate ring system that showed structures far more complex than anyone had imagined. Each planetary encounter expanded our knowledge of the solar system's architecture while using gravitational assist to propel the spacecraft toward its ultimate destination in interstellar space. Project scientist Edward Stone marveled at how the mission consistently surpassed all initial goals and expectations, providing discoveries that revolutionized multiple fields of astronomy. The Grand Tour established Voyager as one of the most successful space missions in human history, setting the stage for even more remarkable discoveries that would come decades later as it ventured into the unknown realm beyond our solar system. The Golden Record. Voyager 1 famously carries the Golden Record, an extraordinary phonograph disc containing sounds and images carefully selected to represent Earth's incredible diversity and humanity's greatest achievements. Conceived and overseen by a team led by renowned astronomer Carl Sagan, this remarkable time capsule includes greetings in 55 languages, music from various cultures spanning classical compositions to folk songs, and natural sounds from Earth's environment including whale songs, thunderstorms, and human heartbeats. The record serves as both humanity's ultimate time capsule and our most ambitious attempt at communication with potential extraterrestrial intelligence that might someday encounter the spacecraft drifting through interstellar space. The Golden Record's ingenious design included detailed instructions for decoding its contents, with diagrams showing how to construct a record player and locate Earth within the galaxy using pulsar map coordinates. Decades later, this golden disc has become an enduring symbol of human unity, curiosity, and our deep desire for connection across the vast cosmos, immortalizing our quest to reach beyond our planetary boundaries and establish meaningful contact with whatever intelligent life might exist among the stars. Years in the void. For more than 4 decades, Voyager 1 has journeyed through the vast darkness of space, continuously transmitting invaluable scientific data as it passed beyond the asteroid belt and entered the outer reaches of our solar system. Despite traveling more than 150 astronomical units from the Sun, a distance so immense that radio signals now take over 22 hours to reach Earth, its sophisticated instruments continue functioning remarkably well, providing unique insights into space weather patterns, cosmic ray behavior, and the complex dynamics of solar-wind interactions. Mission operations at NASA's Jet Propulsion Laboratory have faced unprecedented challenges including steadily weakening power levels, extreme communication delays, and the need to manage aging systems designed in the 1970s using modern computer technology. Engineers have performed miraculous feats of remote troubleshooting, developing innovative techniques to maintain spacecraft health across interstellar distances while conserving precious power resources. Voyager 1's extraordinary longevity represents a testament to both robust engineering design and humanity's persistent determination to explore frontiers far beyond our known boundaries, proving that human ingenuity can overcome seemingly impossible technical challenges. Crossing the boundary. In August 2012, Voyager 1 achieved a historic milestone by crossing the heliopause, the mysterious boundary where the sun's influence dramatically diminishes and true interstellar space begins. This unprecedented achievement represented humanity's first tentative step into the vast galactic environment beyond our solar system's protective bubble. Scientific instruments on board detected dramatic changes in plasma density, magnetic field strength, and cosmic ray intensity, providing definitive evidence that the spacecraft had entered an entirely new cosmic environment never before directly explored by human technology. The spacecraft's signals confirmed that solar wind particles had given way to the interstellar medium, a historic validation of decades-old theoretical models about the heliosphere's structure and behavior. Mission scientist Ed Stone heralded this discovery as a triumph of human exploration, marking humanity's transition from inhabitants of a single solar system to active explorers of the broader galactic neighborhood. Subsequent measurements have continued refining our understanding of this complex boundary region, revealing unexpected turbulence and magnetic field configurations that challenge existing models. This crossing established Voyager 1 as humanity's first true interstellar spacecraft, opening entirely new chapters in space exploration and cosmic discovery. Signals from nowhere. Voyager's sophisticated instruments have detected enigmatic radio signals emanating from regions far beyond our solar system, creating one of the most perplexing mysteries in modern astrophysics. These mysterious signals from nowhere exhibit unusual patterns and characteristics that remain inconsistent with any known natural sources or previously understood cosmic phenomena. Leading the investigation into these anomalous transmissions, astrophysicist Donald Gurnett and his research team continue analyzing whether these signals originate from interstellar plasma oscillations, unknown cosmic ray interactions, or potentially even more exotic phenomena that challenge current understanding of physics. Some researchers hypothesize that these signals might result from interactions with mysterious magnetic structures, unknown particle fields, or previously undiscovered processes operating within the interstellar medium itself. The phenomenon has forced scientists to reconsider existing astrophysical models and may point toward entirely new physics operating in the vast spaces between stars. These continuing discoveries affirm that our galaxy remains profoundly mysterious, harboring phenomena that extend far beyond current scientific comprehension, and suggesting that interstellar space contains secrets that could revolutionize our understanding of cosmic processes and the fundamental nature of reality itself. The temperature mystery. Temperature measurements from Voyager 1 continue defying initial scientific expectations and creating new puzzles about the nature of interstellar space. Despite existing in the supposedly frigid environment beyond the heliosphere, instruments aboard the spacecraft have recorded unexpected temperature fluctuations and anomalously warm zones that challenge conventional models of interstellar medium behavior. Leading researcher Bill Kurth and his colleagues have analyzed extensive data suggesting complex thermal processes and unprecedented turbulence occurring in this mysterious boundary region between solar and galactic environments. These surprising findings significantly complicate existing models of interstellar medium properties, implying far more dynamic and complex interactions between particles, magnetic fields, and energy sources than previously theorized by astrophysicists. The temperature anomalies suggest active heating mechanisms that could involve magnetic field reconnection events, shockwave propagation, or entirely unknown physical processes operating on galactic scales. Understanding these thermal mysteries offers crucial insights about our sun's broader galactic environment and potential hazards that future spacecraft might encounter when venturing beyond our solar system. The discoveries underscore how much remains unknown about the cosmic environment surrounding our solar system and the fundamental processes shaping interstellar space. Changing course. Voyager 1's trajectory has exhibited subtle but measurable course changes over time, creating new mysteries about forces operating in interstellar space. These deviations appear to result from complex gravitational influences and unexpected interactions with interstellar matter that weren't fully anticipated by mission planners. Analysts at NASA's Jet Propulsion Laboratory, including project scientist Suzanne Dodd, have carefully documented trajectory deviations that cannot be completely explained by existing models of solar gravitational effects alone. The observed course changes may arise from interstellar wind pressures, gravitational effects from unseen cosmic structures, or potentially even interactions with dark matter concentrations or gas clouds drifting through our local galactic neighborhood. Continuous tracking and sophisticated data analysis provide valuable insights that inform navigation strategies and propulsion requirements for future deep space missions venturing beyond the heliosphere. These findings highlight the remarkably dynamic nature of the galactic environment and demonstrate the critical need for adaptive mission designs capable of responding to unexpected conditions. The trajectory modifications reveal that interstellar space contains forces and influences that extend far beyond current scientific understanding, suggesting that future interstellar missions will face challenges that remain largely unknown and unpredictable. Ghost in the machine. The spacecraft's onboard systems occasionally exhibit unexplained glitches and anomalous behavior that has led some mission specialists to speculate about a metaphorical ghost in the machine affecting Voyager's operations. NASA engineers continuously address these technological anomalies through increasingly sophisticated remote troubleshooting techniques, working across impossible distances to maintain spacecraft functionality. Some hypothesized issues relate to cosmic radiation impacts, gradually affecting electronic components, while others may result from normal aging processes in hardware systems originally designed for much shorter operational lifespans. The mysterious nature of these intermittent glitches adds a distinctly human element to the otherwise mechanical journey of Voyager 1 through the cosmic void. Mission engineer Linda Spilker frequently remarks on the extraordinary challenges of operating technology that's now over 4 decades old, while maintaining functionality across interstellar distances that test the absolute limits of human engineering capabilities. These technical anomalies serve as constant reminders of the spacecraft's remarkable resilience and the incredible ingenuity of the engineering teams who continue supporting its mission. The glitches also highlight how little we understand about the long-term effects of interstellar environment exposure on sophisticated electronic systems, creating valuable lessons for future interstellar mission design. Patterns within patterns. Voyager 1's continuous stream of scientific data has revealed intricate nested patterns in cosmic rays, magnetic fields, and plasma waves that researchers have dubbed patterns within patterns, complex structures that hint at deeper organizational principles operating throughout interstellar space. Leading physicist Donald Gurnett uses these unprecedented observations to develop sophisticated computer models of the interstellar medium's complex structure, revealing organizational patterns that extend across vast scales throughout our local galactic neighborhood. These nested fluctuations and systematic variations hint at turbulent cascade processes and magnetic reconnection events that may be actively shaping the galaxy's environmental conditions over cosmic timescales. The continuous analysis and interpretation of such cosmic complexity underscores the virtually endless frontier that astrophysical research represents and humanity's enduring quest to understand our place within the broader universe. Each new data transmission from Voyager reveals additional layers of cosmic organization that challenge existing theoretical frameworks and demand new approaches to understanding galactic physics. The discoveries demonstrate that even the seemingly empty spaces between stars contain rich, dynamic structures that influence cosmic evolution processes. These patterns suggest that interstellar space operates according to fundamental physical principles that remain largely mysterious, despite decades of intensive scientific investigation and theoretical development. Voyager 1's impossible encounter with the mysteries of deep space has both confirmed our worst fears and revealed profound cosmic secrets that challenge everything we thought we knew. As humanity's first interstellar ambassador, it continues providing unprecedented insights into phenomena beyond our solar system. The spacecraft's remarkable journey highlights both human ingenuity and the vast mysteries awaiting discovery in the cosmos. Which of these revelations surprised you most? Share your thoughts below. If you found this cosmic journey fascinating, hit like, share with fellow space enthusiasts, and subscribe to Future Facts for more extraordinary discoveries from the final frontier. What if the most terrifying message from the stars wasn't a broadcast but an object? And what if that object wasn't just visiting but reporting back to something else? In 2025, officials confirmed the detection of our solar system's third interstellar visitor, an object designated 3I Atlas. But as they decoded its transmissions and analyzed its impossible flight path, they confirmed a fear that humanity has held for centuries. This wasn't a random rock, it was a messenger. Let's explore this together. The impossible visitor. So, what happens when a visitor from another star system doesn't just tumble through, but navigates? When the Vera C. Rubin Observatory in Chile first flagged 3I Atlas in early 2025, it immediately defied every known classification. Unlike our previous interstellar guests, this object exhibited something that sent a chill through every Mission Control Center-controlled flight patterns. Dr. Karen Meach, a University of Hawaii astronomer renowned for her work on Oumuamua, was among the first to note that its trajectory was non-ballistic to a degree that is simply not natural. It executed deliberate, impossibly precise course corrections. Its sheer scale was staggering, It was surrounded by a massive 700,000-kilometer coma, a glowing envelope of gas and plasma nearly half the diameter of our own sun. But unlike a comet's coma, this one didn't sublimate chaotically, it pulsed, beating like a cosmic heart with powerful electromagnetic signals at a frequency of 1.42 gigahertz. The hydrogen line, a frequency famous in SETI circles, firing in a perfect rhythm once every 147 seconds. As this impossible visitor carved its way through our asteroid belt with surgical precision, one chilling question began to emerge. What if this thing wasn't exploring, but was actively reporting back? When physics stopped making sense. Here's where the story takes a sharp turn from a scientific curiosity into a genuine threat. Most objects from beyond our solar system follow chaotic trajectories, their paths dictated by gravity. But 3I Atlas demonstrated something entirely different. Its path allowed it to drift past several planets in ways that maximized gravitational efficiency, a maneuver that reminded JPL engineers of complex gravity assist routes they designed for probes like Voyager. When celestial mechanics experts like Jacques Lascar from the Paris Observatory ran the orbital simulations backward, they discovered something statistically impossible without intelligent intervention. The path of 3I Atlas required navigating through dense meteoroid streams and planetary collision zones with a mathematical elegance that was simply breathtaking. Its trajectory deviated from a purely gravitational path by a measured 0.05 arcseconds per hour, a tiny but constant thrust that had no visible source. It moved like a grandmaster's chess piece on a cosmic board, avoiding every conceivable threat with a precision that suggested either advanced, long-term planning or sophisticated real-time control. This wasn't a random space rock wandering through the cosmos, it was, as some scientists began to describe it, exhibiting piloted behavior. The object that defied reality. The unsettling feeling that we were dealing with something far beyond our comprehension only intensified when NASA, under the guidance of senior JWS scientists like Dr. Jane Rigby, pointed the James Webb Space Telescope toward 3I Atlas. The results that came back didn't just challenge our understanding, they completely rewrote the rulebook. The thermal readings showed a consistent, stable temperature of 120 Kelvin, with rhythmic heat emission patterns that pulsed in sync with its radio signals, a behavior that defies thermodynamics. Webb's spectrography revealed materials never before seen, including hyper-reflective compounds that returned almost 99% of the light that hit them. But the most disturbing discovery was a faint, recurring electromagnetic anomaly echoing from within. This low-bandwidth frequency at 408 MHz, repeated every 147 seconds, matching the exact signature of a known pulsar, PSRB 1919+21. The problem, as any physicist would attest, was that the object had no spinning core, and no magnetic field capable of generating such a signal. It appeared to be mimicking something it had encountered, or worse, actively communicating with something beyond our detection capabilities. 2 visitors, 1 terrifying pattern. The mystery deepened significantly when researchers cross-referenced 3I Atlas's electromagnetic signature with archived data from Oumuamua. The comparison revealed something that sent shockwaves through the scientific community. The exact same 147-second frequency had been detected briefly in Oumuamua's data, a faint 3 sigma detection that was initially dismissed as noise. The crucial difference was that 3I Atlas's signal was a powerful, sustained 50 sigma detection, an unmistakable beacon. This discovery, championed by controversial Harvard astronomer Avi Loeb, completely reframed our understanding of both objects. Oumuamua had puzzled scientists, but now a disturbing pattern emerged. The evidence suggested that Oumuamua may have been a reconnaissance probe. If this theory held merit, then 3I Atlas represented something far more significant, not passive observation, but active engagement. It was the difference between a single radar ping and a fully operational surveillance system. Some researchers now theorize that Oumuamua was the lock, and 3I Atlas is the key, designed not just to observe but to unlock something, whether buried on our planet or awaiting activation in orbit. When space objects make calculated decisions. Just when scientists believed they had mapped 3I Atlas's future trajectory, the object performed a maneuver that shattered every remaining assumption. Telescopes in Chile and Hawaii recorded a subtle but unmistakable course shift that couldn't be explained by gravity or solar wind. The object veered slightly off its projected arc, executing a 15-meter-per-second delta V that realigned its vector, bringing it 0.1 astronomical units closer to Earth's orbital plane. To mission analysts at NASA's Deep Space Network at JPL, the implications were alarming. The timing and precision of this maneuver implied conscious decision-making. The maneuver occurred precisely when the James Webb Space Telescope had achieved its optimal tracking position, suggesting the object was not only aware of our surveillance efforts, but was reacting to them. This transformed 3Y Atlas from an astronomical curiosity into a potential confirmation of technologies far beyond our own. It was no longer a passive object of study, it was an active participant in a cosmic dialogue we didn't know we were having, a dialogue that was now escalating. Ancient mathematics from the stars. As if its movements weren't enough, independent cryptographers at the SETI Institute, inspired by the lifelong work of pioneers like Dr. Jill Tarter, uncovered something extraordinary. Using Fourier analysis of the pulse's phase modulation, they found precise mathematical ratios hidden within the signal, the golden ratio, Fibonacci sequences, and the first 100 prime numbers encoded in binary. These weren't arbitrary concepts. They represent fundamental codes that appear throughout the natural universe. The precision of these patterns suggested a level of mathematical sophistication far beyond random cosmic noise. Even more disturbing was the dynamic nature of these signals. The mathematical patterns weren't constant, they changed subtly, reacting to solar activity and even our own radio emissions. Most chilling of all, researchers detected a brief disruption, a single skipped pulse that matched exactly with the moment James Webb first locked onto it. The object appeared to know it was being observed and had responded with a mathematical fingerprint that spoke a language older than human civilization itself. Organic chemistry from beyond the stars. James Webb's detailed spectroscopic analysis revealed another disturbing layer to the 3I Atlas mystery. The telescope detected complex carbon molecules on the object's outer shell, specifically polycyclic aromatic hydrocarbons, which, are the building blocks of prebiotic chemistry. These compounds, as astrobiologists like Carl Sagan have long theorized, are the precursors to life itself. What was alarming was the purity and organization of these molecules. Unlike the chaotic mixtures found in comets, the compounds on 3Y Atlas showed 99.9% isotopic consistency, a level of molecular organization that just doesn't occur naturally in space. The spectral lines at 3.3 micrometers, a key signature of PA8s, were honestly, unnaturally sharp and clear. Some researchers, including those at MIT under the guidance of experts like Dr. Sarah Seeger, began to theorize that 3Y Atlas might represent a seed ship, an ancient vessel designed not just to explore, but to plant the foundations of life on suitable worlds. If this theory held merit, then Earth's location along the object's trajectory might not be a coincidence at all. When Earth responded to the cosmic visitor. The connection between 3I Atlas and Earth became far more unsettling when a classified high-altitude surveillance balloon managed by the U.S. Antarctic program detected something extraordinary. The balloon's instruments recorded a powerful microwave burst at 23.5 gigahertz, sharp and centered precisely above the South Pole. Initially dismissed as interference, its timing aligned perfectly with another angular shift in 3Y Atlas's trajectory. Moments after the burst, seismic stations that are part of the global seismographic network recorded ultra-low-frequency rumbles across the frozen continent. These deep, resonant frequencies were a perfect 0.0068 Hz, the exact inverse of the 147-second pulses being emitted by 3I Atlas. The synchronization was impossible to dismiss as a coincidence. Somehow, this visitor appeared to be influencing activity on our own planet, possibly triggering responses from systems buried deep beneath the Antarctic ice. The object wasn't just passing by, it was actively interacting with Earth in ways that suggested a technological sophistication far beyond our current understanding. The Asteroid Belt Death Run. 3I Atlas is currently navigating through the main asteroid belt, a phase that presents unprecedented risks. Unlike other objects, 3I Atlas cuts directly through the belt's core at a low 5-degree inclination, passing through a region with a particle density 50% higher than the belt's average. The object, moving at a blistering 42 kilometers per second, is surrounded by its massive 700,000-kilometer coma, creating unprecedented interactions with the billions of objects in the belt. Planetary scientists at institutions like the Southwest Research Institute are watching with bated breath. As 3I Atlas moves through this environment with its powerful electromagnetic signature, it's creating disturbances never before observed. While a direct collision remains statistically low, its gravitational and electromagnetic effects could potentially alter the trajectories of other bodies in unpredictable ways, creating a cascading effect or, more concerningly, redirecting the object itself toward Earth's orbital path. This is a cosmic gamble with planetary consequences. Rewiring our solar system's neural network. Scientists have now discovered that 3I Atlas's interaction extends far beyond simple gravitational effects. Its complex, dusty plasma envelope is actively interacting with the solar system's magnetic field, creating what researchers are calling an electromagnetic web effect. As 3I Atlas cuts through the inner solar system, it could be generating packets of charged dust that flow along the sun's natural electric currents toward Earth, potentially triggering geomagnetic storms. But the most disturbing discovery is the most recent. Observations from the Allen Telescope Array show that 3I Atlas has begun emitting a secondary signal, a lower frequency, longer pulse at 700 MHz pointed directly toward the Orion constellation. As SETI astronomer Seth Shostak noted, a signal not pointed at us is infinitely more chilling. Some researchers believe it's calling for reinforcements. Others think it's reporting back on its findings. But either way, one conclusion seems undeniable. This was never just an interstellar rock. This was a node, a probe, a messenger, broadcasting to something else that is still on its way. The story of 3I Atlas is far from over. In fact, it may just be the beginning of a much larger, more terrifying story. The mounting evidence, the deliberate course corrections, the mathematical signals, the organic chemistry, and now a broadcast pointed toward deep space, all suggest that this object is not the main event. It is a precursor. It is an announcement that our solar system is no longer a quiet, isolated neighborhood. We may have just accidentally triggered a sequence of events that will fundamentally change humanity's place in the universe, and we are completely unprepared for what comes next. Thank you for watching Future Facts. On July 1, 2025, astronomers discovered something extraordinary racing through our solar system. A massive interstellar object designated 3I/Atlas that dwarfs all previous visitors from beyond our cosmic neighborhood. This colossal traveler, potentially up to 12 kilometers wide, is moving at over 150,000 miles per hour on a trajectory that confirms its origin from another star system. Unlike the mysterious Oumuamua or the smaller comet Borisov, 3I/Atlas represents our largest confirmed interstellar visitor, offering unprecedented opportunities to study material from distant worlds before it vanishes forever into the cosmic void. The historic discovery. What started as a routine night of sky surveillance on July 1, 2025, became one of the most significant astronomical discoveries of the decade. The Atlas Survey Telescope in Rio Hurtado, Chile, operated by the University of Hawaii as part of NASA's Planetary Defense Network, detected an unusual moving object approximately 670 million kilometers from the Sun. Initially catalogued as A11PI3Z, this faint dot immediately caught astronomers' attention due to its peculiar trajectory and unexpected brightness. The Asteroid Terrestrial Impact Last Alert System, known as ATLAS, consists of 4 telescopes strategically positioned across the globe. 2 in Hawaii, 1 in Chile, and 1 in South Africa. These automated sentinels continuously scan the night sky, photographing the same regions multiple times to detect moving objects that might pose threats to Earth. However, what they discovered on that July night was something far more extraordinary than a potentially hazardous asteroid. Confirming interstellar origins. The confirmation that 3I/Atlas originated from beyond our solar system required careful analysis of its orbital mechanics and trajectory. Unlike objects native to our cosmic neighborhood, which follow predictable elliptical paths around the Sun, interstellar objects travel on hyperbolic trajectories, essentially one-way tickets through our solar system. Dr. Paul Chodas, director of NASA's Center for Near-Earth Object Studies at the Jet Propulsion Laboratory, explained that the object's velocity and trajectory definitively prove its interstellar nature. When astronomers traced its path backward through space, they found it approaching from the general direction of the galactic center, though pinpointing its exact stellar origin remains impossible due to the vast distances and timescales involved. The object's designation as 3I/Atlas reflects its historic significance. The 3I indicates it's the third confirmed interstellar object ever discovered, following 1I/Oumuamua in 2017 and 2I/Borisov in 2019. The Atlas portion honors the survey system that first detected it, while its formal comet designation C/2025N1 indicates it was the first non-periodic comet discovered in the first half of July 2025. What makes this discovery particularly remarkable is the object's speed relative to the Sun, approximately 60 kilometers per second or about 134,000 miles per hour. This velocity is far too high for any object gravitationally bound to our solar system, providing conclusive evidence of its interstellar journey. Unprecedented size and characteristics. The sheer scale of 3I/Atlas sets it apart from all previous interstellar visitors. Current estimates suggest the object measures between 5 and 15 kilometers in diameter, making it potentially dozens of times larger than Oumuamua, which was only about 400 meters long. If confirmed at the upper end of these estimates, 3I/Atlas would be the largest interstellar object ever observed. Dr. Darrell Seligman, an astrophysicist at Michigan State University, who has been studying the object since its discovery, describes 3I/Atlas as shockingly bright despite its enormous distance from Earth. This brightness could indicate either exceptional size or an unusually reflective surface composition. The object's luminosity allows telescopes to observe it clearly even though it remains much farther from Earth than Oumuamua was when discovered. Early spectroscopic observations reveal that 3I/Atlas exhibits a reddish hue, similar to objects in the outer regions of our solar system. This coloration suggests the presence of organic compounds and complex hydrocarbons that have been altered by billions of years of cosmic radiation exposure. Perhaps most intriguingly, 3I/Atlas shows clear signs of cometary activity, including a faint coma, a hazy envelope of gas and dust surrounding the nucleus. This activity indicates the presence of volatile materials like water ice, carbon dioxide, and other compounds that sublimate when heated by solar radiation. Comparing the interstellar visitors. The discovery of 3I/Atlas gives astronomers their third data point for understanding interstellar objects, and honestly, it reveals some fascinating diversity among these cosmic wanderers. Each visitor has exhibited unique characteristics that, well, really challenge our expectations about objects from beyond our solar system. Oumuamua, discovered back in October of 2017, is still the most enigmatic of the three. Its extremely elongated shape, lack of visible cometary activity, and that mysterious non-gravitational acceleration, these all sparked intense debate about what it really is. Comet 2Y Borisov, discovered in August 2019 by amateur astronomer Gennady Borisov, turned out to be more conventional in its behavior. This object clearly showed typical cometary characteristics, including a visible tail and a composition similar to comets in our own outer solar system. 3I/Atlas, though, seems to bridge the gap between its predecessors while introducing a whole new set of mysteries. Like Borisov, it shows cometary activity, but its enormous size and those unusual brightness patterns definitely set it apart. Dr. Mark Norris from the University of Central Lancashire notes that 3I/Atlas doesn't look like either of them, which is crazy and exciting. The rapid succession of these discoveries, 3 interstellar objects in less than a decade after centuries of seeing none, suggests, such visitors may be far more common than we ever thought. Advanced Observational Campaign. The astronomical community has really mobilized an unprecedented international effort to study 3I/Atlas before it disappears into the depths of space. Unlike Oumuamua, which was discovered as it was already leaving the solar system, 3I/Atlas was detected early enough to allow extended observation campaigns using the world's most powerful telescopes. The James Webb Space Telescope, with its exceptional infrared sensitivity and massive 6.5-meter mirror, is perfectly positioned to analyze the object's composition and thermal properties. Webb's instruments can detect specific molecular signatures in the comet's coma and tail, potentially revealing the presence of water vapor, carbon monoxide, methane, and other volatiles that could provide clues about its origin. The Hubble Space Telescope continues to monitor 3I Atlas using its ultraviolet and visible light capabilities, complementing Webb's infrared observations. Together, these space-based observatories provide a comprehensive view across multiple wavelengths of light, revealing details impossible to obtain from ground-based telescopes alone. Ground-based observatories worldwide have also joined the effort. The Very Large Telescope in Chile, the Keck Observatory in Hawaii, and numerous other facilities are tracking the object's brightness variations, rotation, and spectroscopic properties. Radio telescopes, including the Very Large Array in New Mexico, are monitoring for any unusual emissions that might indicate unexpected activity or composition. This coordinated global effort, honestly, represents the most comprehensive study of an interstellar object ever attempted, taking advantage of technological capabilities that just weren't available during previous encounters. Ancient origins and cosmic age. Recent research suggests that 3I Atlas may be one of the oldest objects ever observed, potentially predating our solar system by billions of years. Dr. Jesse Hopkins and his colleagues at the University of Oxford have developed models indicating that this interstellar visitor likely formed around an ancient metal-poor star in the galaxy's thick disk, a population of stars that formed when the Milky Way was much younger. Professor Chris Lintott, co-author of the Oxford study and presenter of BBC's The Sky at Night, explains that there's approximately a 2/3 chance this comet is older than our 4.6 billion-year-old solar system. If confirmed, 3I Atlas would represent a pristine sample of materials from the early galaxy, preserved in the deep freeze of interstellar space for eons. The object's ancient origins could explain its unusual characteristics. Unlike comets in our solar system, which have been repeatedly heated during passages near the Sun, 3I Atlas may be experiencing its first encounter with stellar radiation in billions of years. This pristine nature could account for its unexpected brightness and activity patterns. Dr. Michelle Bannister from the University of Canterbury notes that the gases released as 3I Atlas is heated by the Sun will test theoretical models about ancient comet composition. This temporal perspective transforms 3I Atlas from merely an interstellar visitor into a potential time capsule from the galaxy's youth. Trajectory and future encounters. So, 3I/Atlas is currently following a precisely calculated path through our solar system that will bring it to perihelion, its closest approach to the Sun, around October 30th, 2025. At this point it will be approximately 206 million kilometers from the Sun, just inside Mars's orbit, but still at a safe distance that poses no threat to Earth. The object's trajectory offers both opportunities and challenges for observation. During its closest solar approach, 3I/Atlas will be positioned on the opposite side of the Sun from Earth, limiting direct observation during its most active period. Dr. Astor Taylor, a graduate student in astrophysics at the University of Michigan, explains that despite the object's incredible speed, astronomers will have several months to study it. The comet will remain visible to large telescopes until early 2026, after which it will fade into the darkness of space, never to return. On October 3, 2025, 3I/Atlas will make its closest approach to Mars, providing an opportunity to measure how planetary gravity might subtly alter its trajectory. The object's outbound journey will take it beyond Jupiter's orbit by mid-2026, beyond Saturn by 2027, and eventually beyond the influence of our solar system entirely, resuming its eternal voyage through the galaxy. Scientific implications and astrobiology. The discovery and study of 3I Atlas carries, honestly, some pretty profound implications for our understanding of planetary system formation, the distribution of organic materials throughout the galaxy, and potentially the origins of life itself. As the largest confirmed interstellar object, it offers an unprecedented opportunity to analyze material from another stellar system in detail. If spectroscopic analysis reveals complex organic compounds within 3I Atlas, it would support theories that interstellar objects serve as vehicles for distributing the building blocks of life across the galaxy. This concept, known as panspermia, suggests that life's ingredients, or even life itself, might travel between star systems aboard comets and asteroids. The object's ancient age adds another dimension to its astrobiological significance. Materials preserved in 3I Atlas for billions of years could contain information about the early galactic environment when the first generation of planets was forming. Dr. Rosemary Dorsey from the University of Helsinki emphasizes that studying 3I Atlas provides insights into the role that ancient interstellar comets play in seeding star and planet formation across the galaxy. The object's composition and behavior could reveal whether the chemical ingredients necessary for life are common throughout the cosmos. The discovery also informs models of planetary system evolution, suggesting that the ejection of material into interstellar space is a common process that connects distant stellar systems through the exchange of matter and potentially biological information. Future detection and exploration. The discovery of 3I Atlas comes at a pivotal moment in astronomy, as new survey telescopes prepare to, really revolutionize our ability to detect interstellar objects. The Vera C. Rubin Observatory, scheduled to begin operations soon, will photograph the entire visible sky every few nights, creating a comprehensive movie of the cosmos that should dramatically increase the rate of interstellar object discoveries. Predictions suggest that Rubin Observatory might detect between 5 and 50 interstellar objects during its 10-year survey, with some potentially as large as 3I Atlas. The discovery also highlights the potential for rapid response missions to intercept future interstellar objects. While 3I Atlas was detected too late for any spacecraft to reach it, several space agencies are developing concepts for high-speed interceptor missions that could be launched on short notice when the next visitor is discovered. The European Space Agency has proposed the Comet Interceptor mission, designed to study a pristine comet or potentially an interstellar object. NASA and other agencies are exploring similar concepts that could provide direct sampling and analysis capabilities, opening entirely new frontiers in space exploration. These future missions could answer fundamental questions about interstellar objects that remote observation cannot address, including their internal structure, precise composition, and the processes that ejected them from their home systems billions of years ago. A new era of cosmic discovery. The arrival of 3I Atlas represents more than just another astronomical discovery. It marks humanity's entry into a new era of cosmic exploration where we can study material from distant star systems within our own solar system. Each interstellar visitor provides a unique window into the processes shaping planetary systems throughout the galaxy. As 3I Atlas continues its journey through our cosmic neighborhood, it carries with it secrets from an ancient star system that may have died billions of years ago. The data collected during its brief visit will be analyzed for years to come, potentially reshaping our understanding of planetary formation, the distribution of life's ingredients, and our place in the galactic community. The rapid succession of interstellar discoveries, from Oumuamua to Borisov to 3I Atlas, suggests that our solar system exists within a busy galactic highway where objects regularly travel between star systems. This realization transforms our perspective from viewing our solar system as an isolated island to understanding it as part of a vast, interconnected cosmic ecosystem. Future generations of astronomers will have access to increasingly sophisticated tools for detecting and studying these cosmic messengers. Each new discovery will add to our growing understanding of how matter, and potentially life itself, spreads throughout the galaxy. 3I Atlas may be just the beginning of a new chapter in human exploration of the cosmos, one where the universe comes to us in the form of ancient travelers from distant stars. The discovery of 3I Atlas opens an unprecedented window into the ancient cosmos, offering humanity its first detailed look at a massive object from another star system. As this colossal interstellar visitor races through our solar system, it carries secrets from a distant world that may have existed billions of years before Earth formed. The data collected during its brief passage will enhance our understanding of planetary formation, the distribution of life's building blocks, and our cosmic heritage. What other ancient messengers await discovery in the depths of space? Share your thoughts below, hit that like button, and subscribe to Future Facts for more incredible cosmic discoveries. Until next time, keep looking up.